My name is Gillian, and today we've got a really exciting topic. We're going to look at a chemistry topic which is about the history of the atom. It's really one of my favorite, and I hope you enjoy it. So let's have a look at the board. We're looking at this big word, and you might recognize it. It has got the word atom in it. Here we go, A-T-O-M, atom, but it's actually Atamos, which is a Greek word, and that is the word which means indivisible, and it is the word that was given to matter, the small particles of matter, by the Greek philosophers, and we have taken the root part of that word atom and we've used it to name the smallest particle of matter, which is the atom. So let's have a look at all the people that were involved in progressing our understanding of matter and what it's made up of. So here we go. On our next screen, we have a timeline. Now, I need to point out something, and the first thing is that this is quite an old timeline, and so you can see that it has got these notations, BC, which is before Christ. So now we use a different notation to represent time and timelines, and that is the common era. So around about here where these dots are, there will be a line, and that is common era, and not error as in a mistake, error as in a period of time, common era. So then before that would be this. We would write BCE, and BCE means before common era. But you can see that if we look at this timeline, that people have started to think about their world and chemistry and matter and physics a long time ago. So we're talking about 500 BCE, before Common Era. We had alchemists. Now, an alchemist is a person who was involved with experimenting with chemistry. So today they would be known as chemists, but their idea was to try and get a base metal to turn into gold, because gold was you were rich if you had gold. So and that's said that you were wealthy. So that's what they were trying to do, the alchemists. And then you can see at around about 400 BCE, before Common Era, we started with the philosophers, the Greek philosophers. As we go along, there are a multitude of people. Lavoisier, he was French. Coulomb, you might know that word. John Dalton. Crookes. The Curies, we're going to have a quick look at the Curies. J.J. Thomson, he was really important. Max Planck. We're starting to get now into the 1900s. That was over 100 years ago. Albert Einstein, I'm sure you all know about him. Millikan, Ernest Rutherford, we've got Niels Bohr, and then we've got Erwin Schrödinger. So we're going to look at a few of these people and what they contributed to our knowledge of the atom today. We're going to look first of all at our Greek people, the Greek philosophers. So it started off with this really happy looking guy over here, Leucippus, yes, I've said it correctly, and he was a Greek philosopher. Now, Greek philosophers were people who just they thought about and they contemplated the world and what was going on around them, and they came up with ideas. His students, Democritus, over here, that's what he looks like, he continued with the idea of matter, and what they proposed was that matter was made up of Atamos, which means indivisible. And here I've got a picture of just a really solid ball, and what they said was an atom or an atomos was solid, it was hard, it was incompressible, you couldn't squeeze it, and it was indestructible, you couldn't take it apart. So that was their idea of an atomos, of an atom, with the building blocks of matter. So they recognized that all matter has to be made up of something, and something that they couldn't see. Okay. Now, before that was a lady called Maria the Jewess. Now, we don't have a picture of her. Obviously, in those times, they didn't have cameras, so it was usually by drawing. People had to paint you or sculpture you, as you saw with the Greek philosophers, a lot of sculptures, which took a long, long time. But what we do have is some pictures of her apparatus. Now, she's said to have developed a whole lot of apparatus for distilling. Now, you can see in this picture, there's like distillation going on here. In this picture here, there's boiling and evaporation to try and get refined and distilled pure substances. So that is what she is remembered for. She is part fact and part myth. So we don't really know her whole story. But she lived around about from 0 to 200. Can you see she obviously wasn't 200 years old, but around that era, we don't know exactly when she was alive, but in that era, the alchemists started to come to the fore, and this is when she was alive, between 0 and 200 CE, which is Common Era. Right. From then, it was a long, long, long time after that, we start getting people who are investigating and running experiments. And I've added in here Robert Boyle. Now, Robert Boyle, you might know from Boyle's law. He was an aristocrat. He had lots of money. He came from a huge family. There were 14 kids. He was the 14th kid to be born. He really had a thing for learning. He was a great learner, a great scholar. He rubbed shoulders with all the people of the day who were interested and curious and putting out information and experimental data. And he is known as the first modern chemist, because what he did was he started experimenting and observing. So he did the experiments, he observed them, he recorded them, and in 1658, okay, so that's quite a long time after we've got the Atamos, he came up with an idea of gases, and he realized that if you squash a gas, if you change its volume, then the pressure of the gas increases. And that's what we know as Boyle's law, and we still know it today. So that's quite a long time ago that this theory has remained sound. We still use it today. No one has been able to disprove it, which means it is definitely fact. Okay. Now, Lavoisier was very interesting. Lavoisier, over here you can see is a picture of him. He was an aristocrat as well. He was French. He was also a really interesting man. He had lots of money. He was involved in all sorts of things, in tax collection and in economics, and he became a lawyer because his dad was a lawyer, but he had a real curiosity for experimenting and for chemistry. And so he is known as the father of modern chemistry. Okay, the father of modern chemistry. What did he do? He was also very particular about experimentation, about recording data, about doing things very systematically and properly. And he came up with oxidation. Now, you'll come across that when you discuss redox reactions. So oxidation, combustion, he looked at that. He looked at gases. He started formulating the principle of conservation of mass, which we also do. So you need to know that conservation of mass. He distinguished between elements and compounds, also very interesting. He was quite important in the system of naming new elements. So at this time, there were a whole lot of people starting to find out what each element was and do experiments around that. And so he named oxygen, hydrogen, and carbon. He found oxygen and hydrogen. And he was the first to use this quantitative procedure. And quantitative means that you are particular about how much is being made, or how much it's being squashed, or how much it's being reduced. And so he would have started to record all the things that he was observing in his experiments. Now, he was a very interesting man. Although he was a revolutionary, he was very liberal in his political views, he was guillotined. So he had his head chopped off in the French Revolution, and it was it was a sad day because he was a brilliant, brilliant man. Okay, so that Lavoisier is very important. He's the father of modern chemistry, right? The next guy who had a huge impact on the atomic structure was John Dalton. Here he is here on my screen. He was an English chemist. Now, he, for me, was really interesting because for me, he shows a grit and a determination to pull himself out of absolute poverty. So he came from a really poor background. His family didn't have money to send him to school. He had no education, or very little education. And he had to go and work when he was 12 years old at a school. So off he went to school to work, to bring in money. When he was 14, went off to the fields and worked as a farm laborer. He didn't like that so much. He went back to the school to work there. And as he was working there, he had access to books and to education. And so he himself made sure that he educated himself. And as he developed curiosity for his world, he started looking at the various areas that he was interested in. And he built himself up to such a degree that he became a famous scientist, a physicist, chemist. He was really, as an individual, I think, an example that you can really pull yourself out of knowing nothing, being ignorant, and just progressing to fulfill your dreams, right? So what did he do for our understanding of the atom? Some of these things are not correct. We'll see as we go along that principles are manipulated and moved so that they represent more of the truth of the things around us. So he did say that atoms are indivisible, which we know is not true, but that's the start of the atomic theory. He said atoms of a given element are identical in mass and properties. Okay, and to some extent he's correct about that we have an element, each element has atoms, and atoms that belong to that element have the same mass. They behave in the same way. Compounds are combinations of two or more different atoms, types of atoms. And we know that when we get a compound, we have atoms that are different, that are joined together in bonding. Then he consolidated this law of conservation of mass, which means that in a chemical reaction, the mass of the reactants will be conserved in the mass of the product. And then he came up with the law of constant composition, which means that if you've got a compound, that compound is not going to change its composition. It is going to remain the same. So if we have something like copper sulfate, it is going to stay copper sulfate. It won't change. Right, I think it's time for a break. We will see you later.